Okay, in this example, we are using a pedigree to track a trait as it moves through a family tree. The trait that we're looking at is called cystic fibrosis. Cystic fibrosis is a genetic disorder that affects the lungs. All right. So in this case here, anyone who is shaded in on this pedigree has cystic fibrosis. So this individual here, this individual, and this individual, these three individuals have cystic fibrosis, and the rest of them are going to be normal. Okay. Now, the other clue that is given to us is that cystic fibrosis is recessive. Okay. I found that information right here. Cystic fibrosis is recessive disorder. Okay. And not having cystic fibrosis is dominant. Okay. So we can have three genotypes. We did a lot of work on genotypes. We could have homozygous dominant genotype, heterozygous genotype, or homozygous recessive genotype. What would the phenotypes of each one of these be? Well, the two dominants, the homozygous dominant, that's going to be normal. All right. And then for the heterozygous, that'll also be normal because there's at least one dominant allele present. Now, for the homozygous recessive one, the last one, that person would have cystic fibrosis because there's nothing but recessive. There's no dominant to cancel it out. All right. So now what we're going to try to do is we're going to try to take our knowledge of genotypes and apply them to this pedigree to figure out what genotypes each one of these individuals has. Okay. So the easiest one to do first is identifying the genotypes of the people who have cystic fibrosis, because the people who have cystic fibrosis, there's only one possible genotype for them. That's the homozygous recessive one. So I'm going to go ahead and fill that in. For every person who has cystic fibrosis, I know what their genotype is. It's homozygous recessive. I'm just going to go ahead and fill that in. All right. Now we have to figure out, okay, how about these three individuals right here that do not have cystic fibrosis? What is their genotype? Well, I know it can be one of two things. It's either going to be homozygous dominant or heterozygous. All right. But which one is it? Okay. So to figure that out, what I'm going to have to do is I'm going to have to use some clues inside of my pedigree, okay, and my knowledge of genetics from earlier on. So let me erase this real quick. All right, so let's take a look at this individual right here, okay? This female, she can either be heterozygous or homozygous recessive, but which one is it? So let's find out. All right, so since she doesn't have cystic fibrosis, she's going to have at least one dominant allele in her genotype, okay? But what is her other one? So let's look to her offspring for that information. Okay, so this particular female, her first child had cystic fibrosis, okay? So this first child right down here, he got one of the recessive alleles from his dad. That's obvious because the dad can only give recessive alleles. So the dad gave him one recessive allele, and then he got this other recessive allele from his mom. So that, boom, that tells us that, hey, this female has to be heterozygous, okay? She donated that recessive allele to her son. All right, so we figured out what hers was. Okay, now let's try to figure out what the other two are in generation 2. All right, the best way to figure this out is to do a Punnett square. So I'm going to draw a Punnett square real quick over here. It's a quick one. All right, I'm going to put the parent who has cystic fibrosis on the top. I'm going to put the mother who is normal on the side. And then we'll do my Punnett square. I'm going to see what the possible genotypes are. All right. So once again, I'm trying to figure out the genotype for these two guys right here who are normal, okay? And according to my Punnett square, the only possible genotypes that would result in normal offspring would be a heterozygous genotype, okay? So I know for a fact that these two are definitely going to be heterozygous. All right, so they're going to be heterozygous. All right. So pedigrees are definitely very useful for not only tracking traits, but also predicting the probability of people who have a history of certain diseases in their family of having offspring with those similar diseases.